All right, the module 4 lab. Honestly, I've not looked at this lab before, so I will probably make a mistake. If it's not too grievous, I will correct it and go on. But hopefully, I don't totally misread any of the statements. It's pretty tiny. Let me zoom a little bit bigger as well. Okay. When Tony Hawk wants to launch himself as high as possible off the half pipe, so he wants to maximize this height here. The skate park is an excellent example of conservation of energy. So what do we know about conservation energy? The kinetic energy for the potential energy at any point is equal to the kinetic energy and the potential energy at any other point, because that is a constant. It's conserved, it's not changed. Okay. Use the internet, your textbook, or notes to define the following terms. All right. You can just put the equations here for this guy, but do go back and make sure you have the answers for this. And honestly, units of energy, and what else is it units of? Units of work, because it's the kinetic energy theorem. State in your own words the law of conservation energy. It is right here. So don't write it like that. Your own words. Talk about the conservation, use the math example, whatever. But a lot of science is making sure that you understand something so that you can explain it to somebody else, so that when you're reading in a newspaper, you know what is going on. Okay. And we have a whole set of PHET, which we can do there now. All right, so you are going to go run that. Make sure you click on all the little buttons right here. It's always super helpful. You would drag that little mass to the right to have a larger mass. So how does kinetic energy change as he moves down the ramp? As he moves up the ramp, how does this potential change? A lot of these you are already going to know. Remember, your total energy is your kinetic plus your potential. Okay. And that is, what do we know about every specific one? You should know that without even doing the lab. It's going to be based on what? Look at the math. Kinetic energy is equal to 1/2 mv squared. And the potential energy at the bottom of the ramp is going to be based on what? So you actually have a numerical answer for the potential energy at the bottom of the ramp. Okay. What happens when the skater is dropped onto the ramp from above the ramp? Same thing. It doesn't matter if they're on a hill or not. You are still conserving energy. And so your energy is changing from one form to the other. So let me just open up this and make sure there's not any weird things on the simulation, or that the simulation is not opening for me. Okay, PHET. Energy. See what comes up. All right. I will add this link into the thing, since that the clickable link is not clicking. Might click for you, honestly, and just did not click for me. But these ones, you do not need to have anything at all to run it. It's already set up, and it should work in multiple different formats. So even if you don't have HTML5, it should still work. I think we're going to start with intro. So energy skate park basics. Okay, we're just going to start over here in the intro. We're going to turn on all these guys. We have the skater here. Oh, we can literally just take them and drop them. So you can see what happened with that speed. Okay, you can see what happened going on that way. Oops, sent them off the thing. There we go. Should we turn on the grid, a reference site, so that we can do some calculations that way? And let's add some pluses, and there, look at that. That is what you're going to use over here on this left side. So I did a plus over here to help you out so that you can see those different items. Okay, and then you can go ahead and get some actual measurements in this one. Again, still make sure you just basically always just click on everything unless it's a distractor. Okay, this guy you can actually put at certain points to measure it. So you can have it at the top. And they fall off over there. Okay. I thought it would come up over on this energy one, but maybe it does not come up over on the energy one. Okay, yeah, it just comes up when you actually. Oh, it's each of these points. Oh, it's each of the little points. See, that's what I said. I haven't done this before. So any of those spots that you needed actual numbers, you can get it right there. And then you could back calculate the speed if you have the kinetic energy, remember. Okay, so lots of cool little things right there. Yeah, and most of the time it's changed, so you can just say increases or decreases. All right, draw the situations. So have that, and then you know what the graph looks like when they are there because you turned on the graph. What's happening at the bottom of the ramp? You will know, and you should also be able to use your information from the course to know when they're at rest, they have no kinetic energy. When they're at the bottom of the ramp, they have no potential energy. Okay, and you can always, like I said, when I finally found it, you can use that little magnifying glassy thing or whatever it's supposed to be, measuring device, and then that's going to pull up the numbers for you. And then you can rank them. If one of the things is the highest, then you just give it the highest part on the bar graph. So you can just put your own scale here on the left side. And there's some more. What would happen here? So you could either go through and spot check all those little dots or just think about it. Where would I have a lot of kinetic energy and basically no potential energy? Potential energies is mass times gravity times height. So where is it going to be pretty much zero? At the bottom of the ramp. Same thing over here. Spot check it for your answers. Okay. And here's your double check to make sure. And most of those are pretty good review questions. I don't see any big sticklers, but do email me if not, and I will get that link in there to help you out. And that, once you finish module 4, then your semester 1 is done. Do not ignore Canvas though. Come on every day, no lie, every day and check your feedback or sit on a page just so that your attendance is recorded. Have a great day.